Hello student, we are going to discuss one question. This question is from NCERT class 12 chemistry part 2 organic and chapter haloalkane and haloarine, and this question is basically example question, example 6.7 first part. Question is predict the order of reactivity of 4 isomeric bromobutane in SN1 and SN2 reactions. So you have to find out order of reactivity of SN1 among 4 isomeric bromobutane and for the SN2 among 4 isomeric bromobutane. Okay, so first of all you have to know what is the formula of bromobutane. So bromobutane formula is C4H9Br. How to form this? This is the bromobutane. Okay, how to form this? We are forming like C4H10, that is the butane. In that butane, if you replace one hydrogen with Br, it will be C4H9Br. This is bromobutane. Thing is, here main challenge is how to draw the isomers of bromobutane. There are four isomers of bromobutane. That is the difficult part. So I'll tell you how to draw it. So first of all, you draw the butane. In the butane, if you remember, in 10th class you have done the there are two isomers of butane. One isomer is basically CH3, CH2, CH2 and CH3. This is the N-butane. Here we are drawing isomers of butane, and after that we'll draw the isomers of the bromobutane. This is the bromobutane. So in the butane we have two isomers. One is the N-butane, that is basically straight chain. Next one is isobutane. Isobutane is CH3, C, CH3, H and CH3. Thin carbon in a straight chain, one is there in a branch. This is your isobutane. Okay. So if you see here in the N-butane, we have two types of carbon. This is 1 degree. This is also 1 degree, and both are identical. First one and last one, both are 1 degree. And middle one, this is 2 degree. This is also 2 degree. Again, these two are identical position. Okay. Similarly, if you go here, this is 1 degree. This is 1 degree. This is 1 degree. So in isobutane, we have a 3 carbon. They are 1 degree, and middle one is the 3 degree. Okay. So while replacing the hydrogen, see here we are replacing hydrogen in butane. In butane we are replacing hydrogen by Br and getting the bromobutane C4H9Br. One hydrogen is replaced by what? Br. Okay. So basically, while replacing the hydrogen in butane, we consider like 1 degree, 1 degree. Both are identical. We'll consider one case. Means 1 degree carbon, hydrogen of 1 degree carbon will be replaced by Br. They are identical position, so you can replace hydrogen either from here or from here. Similarly, you can replace hydrogen from 2 degree. Again, these two are identical position, so you can replace hydrogen either from here or from here. Okay. So first we'll draw the two isomers here. Isomers number 1. So isomers number 1. So CH3, CH2, CH2, CH2. So these two are identical. So you can replace hydrogen either from here or from here. So basically I'm going to replace hydrogen from here. Okay, from 1 degree. From 1 degree you can take this 1 degree also, it will be same only. Okay, so this is 1. So here we have replaced hydrogen in 1 degree. Similarly, if you go in the second one, okay, second isomer is CH3, CH2. Again we have a 2 degree. Okay, both are identical, so you can replace hydrogen by Br either here or here, any place is fine. CH3, then we have a CH, Br and the what? CH3. So now we have drawn two isomers from here, from the N-butane. One isomer at 1 degree, either here or here. Another isomer from 2 degree, either here or here, because both are identical. Okay. Similarly, we can draw two isomers from the isobutane. In that isobutane, this 1 degree, 1 degree, 1 degree, they are what? Identical, and means we have one identical 1 degree. So either you can replace hydrogen by Br here or here or here, any place. Okay, and then another isomer will be at 3 degrees. So you can replace this hydrogen by the Br at 3 degree carbon. Okay. here we are going to draw the third isomer. Third isomer, 1 degree carbon. 1 degree carbon will be replaced by Pr. So you can replace any 1 degree carbon either here, from here, here or here. So CH3, CH, CH3 I'm going to replace here. So this will be CH2 and Br. Fourth one is, now these three are identical, so we can replace any hydrogen here, at one place by Br, and there is a third isomer. Fourth isomer will be at this position, means 3 degree carbon. So fourth isomer is CH3, CH3 and what? Br. So totally we have 4 isomers. Isomer 1 at 1 degree carbon, isomer 2 at 2 degree carbon. These two isomers we are getting from the straight chain, from the N-butane. Okay, the remaining 2 isomers we are getting from the isobutane, branched one. In the branched one, again we have 2 possibilities. One is the 1 degree, 1 degree, 1 degree, they are identical, so you can replace hydrogen at this 1 degree or here any place, that's fine. Or then we can replace at 3 degree. So here we have replaced here this hydrogen by Br, and another at the 3 degree. Okay, that is the fourth isomer. So this is 1 degree carbon and this is 3 degree carbon. Okay, now we have to find out again. If you see the question is predict or find out the order of reactivity, means rate of reactions of 4 isomeric bromobutane. The challenge was to draw 4 isomeric bromobutane. That was the first challenge. I have drawn all 4 isomeric bromobutane here. I have drawn here all 4 isomeric bromobutane. Among them, we have to find out order of reactivity of SN1 and SN2. Okay, so first we'll go for the SN2, rate of SN2, among these 4. Okay, for the SN2, rate of SN2 directly proportional to stability of transition state, or inversely proportional to, you can say, the crowdness. Inversely proportional to what? Crowdness. So, and you must be knowing rate of SN2 also depends, rate of SN2 versus crowdness, or you can say 1 degree rate of SN2 is more than 2 degree than what? 3 degree, because in 1 degree crowdness is less, 2 degree crowdness is more, 3 degree crowdness even more. Okay, so if you see here, this is 1 degree, here we have maximum rate of SN2, here we have a 3 degree, here we have minimum rate of SN2. So here this is 1 degree, this is 3 degree. Okay, so rate of SN2 in the 1 degree, the rate of SN2 here, maximum is there in case of first, then minimum is there in case of fourth. So this one and this one is first and last is done. Now we have remaining two. So thing is, you must have a questions like this is 1 degree, this is also 1 degree. So why we have selected this? Because this is straight chain, there is less crowdness. Here we have a branch, so there is more crowdness here. So this 1 degree will have more rate than this 1 degree. Okay, now another two are 1 degree and what? 2 degree. First and last is okay. This is 1 degree, this is what? 3 degree. Here we have maximum rate, here we have minimum rate. Now this is what? This is again 1 degree, this is 2 degree. Anyway, even though we have branching is nearby, but still this is 1 degree, this is 2 degrees. So rate in 1 degree is more than the 2 degree. So rate in case of 3 is more than what? 2. More than 2. So I repeat here, first is the 1 degree, last one is 3 degree. Okay, second one is 2 degree, and this is again 1 degree. Then how we are comparing this 1 degree, because this is less crowded, this is what? More crowded. Okay, repeat, rate of SN2 inversely proportional to crowding. Normally most of the students, they are knowing rate of SN2 1 degree is more than 2 degree than 3 degree. So here fourth one is 3 degree, rate is minimum. This then 2 degree, then we have a 1 degree, 1 degree, we have a 2 1 degree. This 1 degree is what, less crowded, this 1 degree is more crowded, so rate is more than this, then 2 degree, then what, 3 degree. This is the in case of SN2. What about in case of SN1? Rate of SN1 inversely proportional to or directly proportional to stability of carbocation. Stability of what? Carbocation. If you form carbocation, the first one if you form the carbocation, this will be CH3, CH2, CH2, CH2 plus first one. This will be the 1 degree carbocation. Second one, if you form the carbocation, CH3, CH2, CH plus and what? CH3. This is 2 degree carbocation. Next one will be CH3, CH, CH3, CH2 plus again this is 1 degree carbocation. And fourth one is CH3, CH3, CH3 and plus this is 3 degree carbocation. Okay, so basically this is 3 degree carbocation, this is 1 degree carbocation. And stability of carbocation, stability of carbocation, 3 degrees more than 2 degrees more than what, 1 degree. So rate directly goes to stability of carbocation. So this is more stable, so rate of SN1 3 degrees more, so that is the rate of SN1 more in 3 degree, then what, 2 degree more than what, 1 degree. Here in our case, where is the 3 degree? Fourth one. Where is the 2 degree? 2 degree is the second one. And when is the 1 degree? Here these two cases we have a 1 degree. Okay, so this carbocation will be more stable because CH3 is nearby. This will put the more minus plus I effect here. 3 and what? 1. Okay. So also the whole thing. Again, question was predict the order of reactivity for isomeric bromobutane in SN1 and SN2. So 4 bromobutanes we have, and in that we have to find out this rate of SN1, rate of SN2. So this is the formula of bromobutane. In that bromobutane, first of all we have to know how to form this bromobutane. C4H9, 1 hydrogen being replaced by what we have, that is the butane becomes bromobutane. In the butane we have 2 isomers, butane itself, that is the N-butane and isobutane. In N-butane we have 2 possibility to replace the hydrogen by Br, that is what, 1 degree, 1 degree, 2 degree, 2 degree. So these 1 degree, 2 degree are identical, 2 degree are identical. So when you replace hydrogen in 1 degree, either here or here, this will be the case. When you replace hydrogen in 2 degree, okay, either here or here, this will be the case we have replaced here. Okay, then in the case of isobutane, again we have 2 possibility, 1 degree, 1 degree, 1 degree, and this is what, 3 degree. So we have replaced hydrogen, you can replace at any 1 degree. Okay, I have replaced here, so I have replaced this hydrogen by Br, and then another case will be 3 degrees. So totally we have 4 isomers. Okay, now rate of SN2 inversely proportional to crowdness or steric hindrance, you can say. Okay, so directly most of the students are knowing rate crowdness is less in case of 1 degree than 2 and 3 degree. So rate of SN2 is more in 1 degree than 2 degree than 3 degree. Okay, so here if you see here, this is 1 degree, this is 1 degree, 2 degree and 3 degree. So rate will be minimum, here. So fourth one, that is the 3 degree rate is minimum. Here we have 1 degree, rate is maximum in case of first one. Again one more we have 1 degree in third case, but this 1 degree is less crowded, this is more crowded. So first one has what, more rate than the third one, and this is obviously 2 degree, so this will be just next to 2 degree. Okay, this is the rate of SN2. Similarly, in case of SN1, rate of SN directly proportional to stability of carbocatene. So better you form carbocatene in all the cases. If you form carbocatene of all the compound, the place of PR. So this is 1 degree carbocatene, 2 degree carbocatene, 1 degree carbocatene, 3 degree carbocatene. Okay, and you know stability of carbocatene 3 degrees more than 2 degrees than 1 degree. Similarly, rate of SN1 also directly stability of carbocatene, rate of SN1 3 degrees more in case of 2 degree than in case of what 3 degree. Okay, so here this is 3 degree, rate will be maximum. This is 1 degree. Okay, rate is minimum. Here we have next to this 2 degree, and to 1 degree we have first and third. So this 1 degree will be more stable just because next to this carbocatene we have a CH3. This is good plus I effect. Okay, so I hope this question is okay for everyone. Okay, so that's it for this question. Thank you for watching this.